Last time we talked about bills of materials and how to configure those and the data collection that goes behind that, and specifically about selecting suitable parts and them being listed and certified for the countries that you want to send the equipment to. That's critical information. Today we're going to talk about part selection. And part selection is critical in building a part that is going to be CE marked, UL listed, and be used in most institutions and across the globe. You really have to select the right parts. Now there's a lot of different nuances to part selection, and I'm going to hit just a few of the highlights today, and then over the next videos we'll pick on some more particular issues. So number one is what type of circuit breaker you pick. These are very important. You want to pick a UL rated branch protected circuit breaker for your main breaker. Other breakers within your device can be supplementary breakers, and you can see this by looking at the UL part numbers. So for your primary overcurrent protection in your equipment, specifically industrial equipment, you want to use a UL 489 breaker. This is a branch protective circuit breaker. You're bringing power into the equipment and then you're distributing around, so you have additional branches and you need to protect that. Downstream of that, if you have a very large piece of equipment, I would suggest continuing using branch protective devices. That UL listed 489 breaker. It's a very great way to do your product. It gives it robustness, and it also gives you the overcurrent protection that you need. Supplemental breakers include UL 1077 breakers. These are pretty much at the end of a branch where you're only feeding one other device. Let's only use those in that case. The difficulty I have sometimes is that customers will use a UL 1077, a supplementary breaker, as the main overcurrent protective device in their equipment. If they do that, I cannot get it UL listed or UL field labeled typically. That means they have to go figure out some kind of other solution to get that product passed. I can provide additional solutions if you have made a design decision to use a lower style breaker, a 1077 breaker, instead of a UL 489 breaker. So if you have questions about that, let me know. Now also for your main power inlet overcurrent protection, that circuit breaker or fuse, you want to pick a large enough overcurrent protective device to work with your facilities where you send your product. So if you're sending an industrial product out for, say, semiconductor, you want to have at least 10,000 amps interrupt capacity. Now if you're using a cord and plugged in piece of equipment, you can drop that number to 5,000. But I still recommend using that UL branch breaker with 10,000 amps of interrupt capacity. Now real quick, what that means is smaller breakers can clear a fault, but if there's a lot of current coming downstream, it might not be enough to break that fault, and it can arc over and cause a fire. So let's say you're in an industrial setting and there's 7 or 8 or 10,000 amps of available fault current. If you have a fault in your equipment and you can't clear that 10,000 amps, it may and likely will arc over and cause a fire. That's a problem. That's why we want to go with the large frame branch protective breakers in your equipment. And also the different standards. We're trying to harmonize your equipment across globally so it can go anywhere. And if you're going to sell it in North America, you're going to want that main branch protective breaker. Now, why part selection is so important, just like I talked about that breaker, is if you don't select the right parts, then we can't get your product certified at the end. We'll have a redesign period. You'll have to reconfigure your equipment. You may have to go out in the field and reconfigure equipment that's already been sold. That's a problem. So if we can get you at the design phase, and that's how HTDS and I can help. We can help you with your part selection at the design phase. That way, very easy to make the change on paper. Once we start ordering parts, building parts, that's way more difficult. So this next one is also very critical. Typically for industrial equipment, your main power inlet wire size should be no smaller than 14 gauge. I get it. A very tiny wire can hold up to 10 amps. However, anything under 14 gauge is going to require you to do other specific things with your overcurrent protection. And you don't want to get involved with that. Let's just go with a minimum of 14. Now there's some other nuances here. Your ground wire may have to be 12 if you have a bunch of leakage current. So we'll talk about that too. Let's get a little further along with this video. Now the other thing that's very critical, if you're building a piece of equipment and you have safety circuits and safety devices in there. And let me give a good example what that'd be. Let's say an interlock to prevent somebody from opening a door and sticking their hand in there and then pulling out a stub. I know that's a horrible idea. It happens. It's terrible. That interlock is there for human safety, to keep them from sticking their hand into the machine. That's the safety part. And then everything else that goes to that interlock and is involved with that interlock has to be fail-safe and safety rated. So a lot of times you'll see it's much easier and cheaper to select a little reed switch, you know, an $8 switch. And they have high reliability, and I understand that, and you can get away with it in some cases. But to get certified, you need that safety rated switch and the safety rated relay to operate it. Now in other cases, like let's say you're using a pressure sensing device to look for and prevent an explosion or an overpressure event, that device needs to be rated too. It needs to be a safety rated device. And you'll do a risk assessment which will get you there and have you understand, and we can help you do that, what rating of part you need. However, if you go out and buy a non-safety rated part and try and use it in a safety functional capacity, we're going to have to help you go back and redesign the equipment. So let's design that in up front. Now let's see, one other thing on part selection that's important. Plastic materials that you use. If you're going to use plastic anywhere in a piece of industrial equipment, you need to be sure that it's UL94V0, meaning it won't catch fire. I recommend don't use plastic anywhere near electrical enclosures or near any ignition sources. If you do use plastic for enclosures and things like that, we're going to have to do the impact testing. So you get how this part selection thing is a very big topic, and it grows and grows. And why it's so critical is I do have a lot of clients who get this right from the start, and I have a small group of clients who miss it, or driven by cost reasons, or this might be the first time they're doing a safety circuit or doing overcurrent protection, and it gets very, very difficult. It's disappointing for them to have to go back and do a redesign. Where to start with your part selection is, what is the part really going to do? Is it a critical part? Is it in your main power? Is it in a safety circuit? Is it going to be are you going to be operating a conductor at 1,000 volts, or are you going to be operating a conductor at 150 C or something crazy like that? We need to be sure that you select the right parts. So that's where we can help out. We can send you documents and help you with part selection in your design phase. And I think this video will highlight 2 or 3 of the big areas that I do see that are a problem. Well, thanks again. If you have any questions, shoot them to me, and look forward to working with you. If you're looking to get your hardware product certified, UL listed, and CE marked, then please like and subscribe below so you can get this information every time we post a new video.